All right, we're back. We are COMP123 in the summer 2017 semester here at Centennial. We are week 10, part 2 of our broadcasts. We're talking again about inheritance and polymorphism. I want to say interfaces again. Inheritance and polymorphism. This is kind of finishing up this topic for this week, right? And then next week, what we're going to do is we're going to handle, we're going to start with collections. We're going to do a little bit more detail on collections. Most likely what I'm going to do next week, just to let you know, is there's going to be some stuff I got to talk about collections. We're going to revisit some of those interfaces, those special interfaces, like the enumerable interface and some of the other ones. And we're going to be then moving right into, on Thursday, probably moving into UI. All right, so we're going to start UI early, only because we need as much time with it as possible. All right, so what did we cover last day? Well, we kind of went into, I'm going to pull up COMP123, the code that I kind of came up with for you. We did lesson 10B for you, right? And I worked with lesson 10A, and one of the challenges was that with lesson 10A that I kind of wrote myself into a corner, and I want to show you this problem, right? So I didn't write it like this in when I was using the code, right? I want to show you lesson 10A and how it's messed up, okay? For people from the first section, they didn't see it because we didn't talk about it, but I kind of wrote myself into a corner here, and what I did was I actually called it get power rank, right, for lesson 10A. So for you guys, I'm switching again. I'm not using lesson 10B. I'm using lesson 10A from the other class. You should be able to recognize it's almost identical, right? But notice what I did. I called it get power rank. And that's kind of wrong, right? Because remember, what we're trying to do here is we're trying to model everything that's inside the real world. We're trying to create a analog for it in code, right? So I see something in the real world, and I want to make it work with code, right? So in my class diagram then, if I go back to my class diagram, it kind of looks like this. I've got my supervillain class, and I've got my superhero class, and I got a couple of interfaces. I'm just going to drag them over here so you can see them here. A couple of interfaces. I has karma, and I has malice, right? So those are two interfaces. I've got my human abstract superclass, right? And my power class that we're using to do stuff with. Okay, that's what I've got right now. But I want to talk about something else, a new concept, and one of the things we didn't really handle so good. But before I get there is I want to modify my superhuman where I have my get power rank. See right here? I want to modify this. Now see what I just did? Let's go back and try that again, right? So I'm looking at my class diagram. Remember, I'm showing you tricks and tips for how to do this, right? I can click on any one of these methods. If I double click on my get power rank, bam, I'm right there, right? So it just takes me right to that part of the code, which is totally useful, right? That's why the class diagram is, like, in my opinion, really useful, right? Okay, so here's my get power rank, but this is wrong, right? Get power rank should be called get power. So I'm just going to rename this thing get power. Now, there's a couple ways I can rename this. I can rename it by right-clicking and rename, right? Or I can rename it manually. Which one do you think I should do? A right-click, refactor, rename, or just rename it? I could, but I like it this way better. So if I do this, if I kind of go into it, and if I right-click and rename, refactoring, right? And what it allows me to do is it says, okay, well, what do I want to rename it to? Well, I want to rename it to get power rank, get power from get power rank, right? And if I click apply, it says include comments, include strings, you know, preview changes, rename will update 3 references in 2 different files. This is the way it should go, guys, right? If I just rename it manually, it's a lot of work for me to do, right? And I might mess it up, right? I might mess something up. So it's like this returns the power rank number. That's what this is cool, but I might mess it up. I might have some finger typing errors or whatever. This one just fixes it up, right? So when I go back to my power, my driver class program. So if I go back to that, so here's my driver class program. And if I look at where I get my power rank from. Here's my power rank. I only did one of these things. Now it just says get power. So it actually renamed it across files, which is really cool, and I highly recommend it. Okay, cool. Let's talk about the stuff that we didn't get a chance to explore. There's only one part I didn't really get a chance to talk about last day that I want to talk about, but there's also another thing. There's actually two things I want to talk about. So one thing is we did not talk about the idea of sealed methods in classes. Okay, so we talked about abstract methods in classes. We talked about concrete methods in classes, but we haven't talked about sealed methods in classes, right? So just like it says here, sealed methods, right? What they do is they lock down, right? They lock down methods or classes from being overwritten or derived from. That's kind of cool, right? So whereas virtual, what virtual does is it allows us to override, or sometimes we must override, right? And it's interesting, it says only methods declared virtual, override, or abstract can be overwritten in derived classes, but a method that's declared sealed in a base class cannot be overwritten in a derived class, right? This is interesting because if you take what it says here, right, and try and apply this one-to-one, it's not going to work exactly as you think it's going to work. So we'll explore that today. So the idea of sealed. The other thing, I want to also explore the idea of implicit versus explicit. Now, you guys have heard this throughout the time that you've been here, if you're a programmer. And I'm going to come up, ask some people, so what's the difference between explicit and implicit? It's another great interview question.
Implicit means that happens by default.
Okay.
System does. And explicit means
Go on, keep going.
I could get that type of one. So we'll force it to do.
Force it. I like it. Okay, so here's what he said. So if I can, so implicit means it's done by default from the class, let's say, and explicit, you're saying that we have to force it. So another way you can think of it is implicit is kind of automatic, right? And explicit is kind of a manual override. We're trying to tell it to do something manually. All right. And so what does that mean? So let's look at some examples of implicit and explicit. Can I implicitly convert one type to the other? Implicitly convert. Can I do that? And yes, I can, right? If I say, if my first data type is a float and I want to convert it to an integer, could I? I could, right? Is it going to be accurate? No, it's going to lose all kinds of detail, right? But I can, right? And it does it automatically. I can just say this integer is equal to this float, and then it's going to just drop off the digits. It's going to lose all its accuracy, right? It's going to truncate the data, right? But I also could explicitly convert, and there's ways to do that, right? Convert to, we can use the convert to function, right, or method that's built in, as well as we can use in parentheses, we can use conversion or casting to cast it from one type to another. That's explicitly cast, right, as opposed to implicitly. So we can also use the same idea of implicit and explicit in our idea of that all private methods are implicitly sealed, right? Because private methods, you can't override them, not really, right? And the same thing goes with static. You can't override static or private methods, right? Because you have no access to them. So implicitly, they're sealed, right? But we should be able to do our lockdown methods explicitly as well, right? And we can do the same thing with this idea of the class itself. If I explicitly lock down the class by calling it sealed, right? Then all the methods are implicitly sealed underneath it, okay? That means they're all sealed just by making the class a sealed class, okay? Now, sealed classes cannot be a base class. That means you cannot derive from this class. And it's a great way of doing this idea of making a class that is a leaf class as opposed to a branch, right? If you're thinking about branches and leaves, right, or a non-leaf class, this should be a leaf class because it ends. It's a leaf. A branch can't come from a leaf, right, in your mind, right? The whole tree branch idea, right? I can create many, many branches of superclasses. But when I come to the leaf, it's done. You can't make a branch of a leaf, right? You can just, it's the leaf. It's the last class, right? And sometimes we want to do that because we don't want that class, whatever we define, being modified by somebody else. And that's why we seal it up. There's an example of that in code. The string superclass, that's capital S for string, is a sealed class, all right? So we cannot derive from the string class, right? Even though it's a complex class, it's not a data type that we talked about before. All right, that's cool. Anyone not understand that? Now, how does it work? So if I was going to implement it, and let's say, for example, I wanted the superhero class to be sealed, right? I can go to the superhero class, not the superhuman class, superhero. Here's superhero class, because this may be a leaf class, right? Because it's like we have human, superhuman, superhero, right? Maybe we want to seal this up. If I double click onto it, and I can go to the top, and I can just put the keyword sealed in there, and then it seals it up, right? If I can spell it properly. How about that? Sealed. There we go. If I seal it up, it doesn't change anything. Like, it still operates. If I control F5 on it, we're good to go, right? We're still running. Everything's fine. There's no problem with either this thing at all. But on the class diagram, it does show that it's sealed. There's no color change, unfortunately. I wish there was. I wish there's a way of modifying the class diagram so you can anything else. I don't know how there's not a way that I know how, but there is no other way. It just says sealed. Just like abstract, just says abstract up here. See? Abstract. So, but that means I can't derive from it. I can't make a subclass of superhero if I did that. This is the last class. This is the very bottom of the hierarchy. Okay? That's what it means. And I want you to have that in your mind, because there's going to be times we want to seal up classes when they're done. We don't want anyone to derive from them. They're going to be the classes that we want to create concrete objects from. Okay? Now, I'm not going to seal this one. I'm just showing you how to do it, but I don't want to do it in my case. I'm just showing all you need to put is the sealed keyword, and we're done. All right, that's cool. Here's a question for you, right? Interfaces. We made interfaces, yeah? And I have two of them in this particular example. I have one interface, right, that's called I has karma, and the other interface that's called I has malice, right? And I can inherit from both of them. Right now, all they have is properties, a karma property and a malice property. But what if, hear me out here, what if they had the same method? Each one of them had a method called, as an example, trains. So I can train my superhero or my villain, right? Both of them have that. Both of them have a method called trains. It's the same method name, trains. What happens? So I have two interfaces that have the same method, and the method must be overwritten. Do I have to write this method twice? Do I write it once? And which one does it take care of? Does it take care of I has karma or I has malice, or does it take care of both? What happens? Really? That's a weird thing, isn't it? Remember we talked about multiple inheritance and how it's really weird? It's really weird because we get into this scenario. In multiple inheritance, if we ever had that thing, which we don't, right? You have two classes, and they provide the blueprint for one class. But what if they have the same methods? What happens? That's the problem. And that's why multiple inheritance is bad, right? Well, there's other reasons too, because now you have a multiple domino effect. You have multiple breakpoints that you can break classes that derive from those, right? But let's suppose you have this multiple inheritance scenario. It's kind of the same thing, right? What we do with interfaces. It's allowed. I can have two interfaces, right? And I can have a method name that is exactly the same, right? So which one does it take care of? We're going to have to explore that today, all right? And some people said both. Some people said only one. Some people say none, right? Let's see how it works. All right, so I have another scenario, and I'm going to make this as a further example. Remember, every time I do stuff on here, guys and girls, it's an opportunity for you to see the this idea of interfaces and abstract classes and everything else over and over again, right? So that way it becomes easier for you to understand. That's what it's for, repetition, right? So let's try this again. I want to make another class. I want you to help me with the name, right? I want to make another class, but here's the scenario in real life. We have villains, right? like Magneto, right? He's a villain, right? In real life, yeah, Magneto, because in real life we have all the comic book characters. I'm joking, right? But in the comic books, they have Magneto. Thank you for that. Magneto, he's a villain, and you have Professor X as an example. He's a hero, right? And then you got people kind of in the middle, right? Like Wolverine, right? He's kind of like not really a true hero, and he's not really a true villain. He's the kind of guy that will kill people, right? But he'll only kill the bad people. And there's actually been a lot of that in our culture lately over the last several years. For example, from 2000 till about 2007, we had all kinds of TV shows with anti-heroes, right? Anti-heroes, or vigilantes, as I like to call them. So think about this now, this idea of these anti-heroes and vigilantes, right? They kind of have both. They kind of can do both things, right? And we kind of root for these guys. Here's an example, Dexter. He's an anti-hero, if you're into that show. It was an old show. Breaking Bad, Walter White, he was kind of an anti-hero, right? Mad Men, when you watch that show, there was a lot of anti-hero in that show, right? And we can think about other anti-heroes that we like to watch as well. Like we said, Wolverine, Batman would be kind of an anti-hero as well, or a vigilante, right? Because Batman kills too if he has to. He doesn't want to, but if he has to, he's got no qualms against it if he has to do it. But Superman, no. Superman is like, well, except for the Superman movie that they came up with, right? Superman is the kind of guy that he doesn't want to kill anybody, right? He's kind of an example of a pure hero, right? And if he does accidentally kill somebody, he's really upset about it, right? And this is where his karma goes down to 0, right? Or maybe it becomes negative. I don't know, right? In the game that we're going to make here, right? But think about someone who has both karma and malice. What's the right name to call them? What would I call this new class? So I got a new class I'm making, kind of in the middle, where that kind of suits Batman, that kind of suits, Wolverine, that kind of suits all these other kind of superheroes. Something in the middle, right? Something in between the two of them, right? Yeah, right? What would you say? What would be the right name for it? Let's think about the name. And think about my scheme here that I got going on. I got supervillain and superhero, and then I got this other thing, right? And the other question I have is, this other thing, should it inherit from superhuman, or should it be from human? Does this thing need to be a superhero, or not, right? And that's the thing, right? When we try and translate ideas that are in, let's say, from real life or from culture into code, which is what we want to do as developers, I need to name it properly, right? Because if I name it properly, when it comes to designing the class, that's a very important aspect. I want to have some ideas. What do you think? You're thinking. I see your. What would you say is the right name? Huh? Okay. How about we use the because you guys didn't have you guys aren't suggesting. Let's just use the anti-hero. Okay, anti-hero is the name. Okay. Why is it a good name, in my opinion? Because it has the word hero in it, which is something like what we're doing. Vigilante could also work as well, but it might be not as clear for some people to understand what vigilante is, right? But I think anti-hero might be the right way to do this. I'm going to move this aside. So I'm going to put this, just to move the diagram a little bit. I'll put the superhero here. Actually, we'll put him on this side. And we'll put the supervillain on this side, just from a conceptualization perspective. I'm going to scroll down a little bit in the diagram, so you can see that they both derive from superhuman, right? And I'm going to create a new class right here that's also going to derive from superhuman called antihero, right? So here's antihero. And what I want to do with this class is I want to do the exact same thing. Here's the difference with this one. I talked about this last day, right? I don't just want to derive from or extend. I don't want just to extend superhuman, right? I also want to implement both I has karma and I has malice. Okay, those are the two options here. So you see those, this is the three things that I want to do, right? So now it's a more specialized class than the other ones in some ways, okay? Question. What's the quick way of expanding all this stuff out so I don't have to code it by hand? Anyone remember? What do I do? Well, if I hover over, you can see this little light bulb, right? Remember the light bulb, right? And if I go over here, it's a quick way of doing it. I can generate the constructor that way. But what I want to do here, just to make it a little different, is I want to put my structure in place. Remember I talked about this? Start coding like this, guys. Private instance variables, right? Public properties. Start organizing your code. Constructors. Do you need to do this? No. Do I recommend it? Absolutely. Private methods. Just organize yourself a little bit more. Public methods, if any, right? So I've got this structure here, right? And I want to kind of implement my Antihero, like kind of down here. And I'm going to move it in there, right? Because my Antihero constructor won't be put where I want it, right? Or will it? Take a look what I've done. I've kind of highlighted this, went up to here, clicked on this, and then let's try this again. So notice that my superhero, it's there, but now what happened? Where'd all that code hinting go away, right? Let's undo that and redo. All right, so let's try this again. So I want to kind of highlight this, go over here, click the light bulb, and go generate. And then I want it to go there, but it goes down there. That's okay, right? Now what I can do is I can move it around, right, by pressing the Alt key, right? So I can move this around, right? Notice I'm doing that. I'm moving it around. I can move it around instead of copy paste, right? Or cut paste. Same thing with this, right? So I can put this in place. Let's put them in place. Show you guys, right? Because you need to be able to do things quickly, right? And I want to take these two things, highlight them all, and then move them up, right? So I can kind of do one of these. So I can, again, I'm going to use the, want to move them up, up, until they're under public properties. Sorry, it's hard to see because of my screen moving around, but there it is. I don't have to cut and paste if I don't want to. I also know that I have to, when I implement this thing, I want to create some private data members, right? Now, I like to call them instance variables. Jake will kill me. He likes to call them fields, right? If you're with Jake, doesn't matter. It means the same thing. So private int underscore karma. I want to do this. This is what's going to carry the data, and int underscore malice. So I got malice and karma, right? I've got my public properties right here. And these public properties haven't been implemented. So of course I'm going to, the gets return something. So this that underscore karma. And the sets set something. So this dot underscore karma is, I'm going to assign it using the assignment operator value, the value keyword, right? You guys have seen this over and over again. Don't be surprised if it's on a test, right? Come on. I mean, I'm showing it to you over and over, right? So you guys should know how to do getters and setters. So getter returns, this dot underscore malice, right? And a setter sets assigning, right? This dot underscore malice is equal to value, all right? So we're doing it together. We're practicing together over and over again. All right, so there's our public properties, our private instance variables, right? Hey, my constructor's okay, but you know, when I get my base constructor, what I like to try and do is I'd like to add some other stuff. But this is okay for my, it satisfies my base class superhuman, but really may not satisfy me for my Antihero. So maybe I want to put it as an int, which is karma, lowercase k, and an int that is malice, right? And then inside my constructor, again, I'm going to do the same thing. I'm going to say this dot karma is equal to karma, and this dot malice is equal to malice. Now I can assign karma and malice in my constructor. Now, do I have to do this way? No, I don't. It's just a quick way of doing it. All right, cool. So I'm good. Am I done? What would you do next? So I'm making a new class. What should I do? Best practices. We've talked about this a bunch of times. How about the guys in the back over there? I want some ideas from you guys. You guys are all hiding, right? Yeah, you guys over there in the back. What should I do? Yeah, what should I do here? Am I done my class? Am I done? What? You're not even concentrating on this? Okay. You're behind? Okay, well, it doesn't matter. I answer. So I got this file I just made. Am I done? Right? Answer's maybe, but not really. What's the real answer? Best practices. What should I do? How about the guys up here? What should I do now? Best practices. Comments. I love it. Yeah, someone's paying attention, right? I want to put some comments, right? Because I want to put this up on GitHub, guys, right? So this guy, GitHub will be part of your exam. All right, it's going to happen, guys. You can't avoid it, right? Don't try and avoid GitHub, right? And that means comments. And then comments are going to be part of your exam too, right? Just like it's part of your assignment. When's your assignment due, by the way? Assignment 4? When's it due? Next Friday, right? Next Friday at midnight. Is there going to be an extension for it? No, right? Just letting you know ahead of time, right? So if you haven't started, start. If you haven't started until today, you're behind, guys. Just letting you know, right? All right, so let's fix this out. So what I want to do is here, I want to go to one of these things and grab some comments. And I don't have to comment it from scratch if I don't want to. Just grab the comments, right? I'm going to go back into my Antihero class and pump it in there because I want, if I can do it properly, because what I want is, I want your name, and today is July 20th. And I was saying earlier today, happy birthday for those people who had their birthday today, whoever that is, right? Out there who are watching this video. And of course, this is the Antihero class. You can put some comments in here. It inherits from or extends the superhuman class and implements both the I has karma and I has malice interfaces. Okay, cool. So there is that. And then, of course, down here, I'm going to say 0.1, which is created the Antihero class. What I'm doing here whenever I do these little version numbers? So all I care about is the last thing I did because it's being taken care of by a GitHub, right? And I showed you how that's done. It's really good to do this because then each file kind of has its own versioning in some ways. You can go back and take a look at it, what's been changed. And if someone else is working on it, typically what you can do is put some other name up here too. So this is who modify it. You can also put in things like date last modified, date created. You can put other details in here if you're working with somebody else, right? I don't need to do that right now because it's just me. But if you were doing it, then you would probably have to do that. All right, so here's karma and malice. Maybe I want to put some other comments here for the class, right? Like things like this is the Antihero class, and you can put other details in here. I'm not going to. I'm just going to do this. I probably want to comment the constructor as well because that's kind of good practice, right? Where I kind of say something like this is the default or main constructor, I should say main constructor for the Antihero class. It takes 3 arguments, and which is name, which is a string, right? Karma, which is an int, and also malice, which is also an int. Notice the signature is right there, right? String, int, right? If I made another constructor with another kind of signature pattern, that would be an overloaded constructor. I can have as many constructors as I want, theoretically, right? Within reason. So, I mean, that's the way we kind of display what the constructor has in it, right? Do I have to do this? Not really, because I have this part right here that does it for me. But I like to put as much detail in my summary as I can, within reason. Okay, and one thing I mentioned in the earlier class, which I wanted to mention to you, is commenting is great. Over commenting, not great. Okay, if I have like a bunch of comments, a whole page of comments in one line of code, and then another whole page of comments in one line of code, I don't want to write essays. Okay, this is not what we're doing here. Okay, we don't have to do some kind of crazy research paper here. This is all just the comments we need so that when I pass this to somebody else, they understand what this thing does. That's it. Inputs and outputs is what I want in the header. Anything beyond that is over commenting, unless there's something inside of my method or constructor or something that I need to explain when I would do inline comments. That's it. Okay, so I've got my Antihero class here. Notice that it inherits from both I has karma and I has malice. And this is a great place to put it up on GitHub. I'm going to go to Team Explorer. I'm going to hook off on this. I'm going to go to Changes. Notice that I added my Antihero class. I'm going to say something like, oh, wait, created Antihero class, right? And commit all, save, home, sync. And when I push, this is going to go, it's going to go to COMP123 S2017 lesson 10A. So if you want to keep track with me, go to 10A for this example. Now, 10B is the completed version, which you can also look at if you want to, but 10A is the one that I'm looking at right now. If you guys are going to pay, if you're paying attention with what I'm doing. All right, cool. So we have these three things here, and they're very similar. And let us try and run this thing to test it, right? Because I want to kind of do Control F5 to make sure it doesn't break anything. It doesn't so far. That's the first thing. And then in my driver class, so let's go to my driver class program. And I want to kind of implement my super or my anti-hero. So I'm going to call it anti-hero. And we'll just call it, let's call him who he is this time around. We'll say Batman. He's my anti-hero, right? And my Batman is a new anti-hero. It's a little bit different than what we did earlier. And we'll just call him Batman or the Batman, whatever you want. And let's say he has two things, karma and malice. They're kind of in balance, let's just say, right? He's kind of a balanced dude. That's why he can survive in the Justice League. Because you know what? He kind of balances his karma and his malice when it comes to it. Maybe he's got more karma than malice. Some people might say, or maybe he's got more of one than the other. Right? And depending on the type of hero, anti-hero you make, and I don't know about Wolverine, but Wolverine sometimes I think has more malice than karma, right? But, you know, it depends on the guy you make. It makes sense from taking the abstract again and making it more concrete with code. All right, so we'll say Batman. We'll say add power. What power does Batman have? Real powers, inborn, not like high technology powers. He's got a high-tech suit too, right? He's got something. He's got something. I think Batman has super intelligence, all right? Because you know what? He's always able to outsmart Superman and other people like that, if you think about it, right? It's an opinion, all right? It's an opinion. I'll accept that. But I think he's got super intelligence. He's way more intelligent than or maybe clever than Superman. And he's able to outsmart him and do things that Superman can't do. So I'm going to call it super intelligence. Now, some people who love Batman may disagree. But I'm going to make it a pretty good rank. He's got a rank of 50. Why? Because he can create his own gadgets too. It's in the movies. It's showing that other people create his gadgets for him, but not really. In the comic books, it's him. He creates his own gadgets, right? So that's why for him to create his own gadgets, he's got to be really high tech. He's kind of a high tech guy, high tech wonder, which means he's got to have some kind of super intelligence. Another guy like that would be Tony Stark, right? He's a different kind of high tech wonder with a different kind of suit, right? He's also pretty intelligent because he makes his own tech. Right? So that's why I go with that. All right, so console write line, we want to kind of write down this string. So Batman, dot toString, all the same stuff we can do. We can demonstrate that it's exactly the same class as the other ones, right? And just to be lazy, I'm going to kind of grab this and put it here. And I'm going to grab this up here, karma, and put it down here so I can just display both. Right, but he's not superhero, he's Batman. And the same thing goes with malice. There we go. And that's really what we talked about last day. We talked about how, and I'm going to run this thing. Right, so now you can see that he does both. Here's Batman, here's some supervillain, some generic supervillain dude, some generic superhero dude. We can modify these later on if you want. But at the end of the day, these guys have only karma or malice. This guy has both. Right? So an idea that you can have multiple, I can have multiple interfaces for one class, right? Which is the idea here, right? So I can further specialize my class and I can include both components. And hear what I just said. It's a component-based model, right? Where I want to add a component or a module onto a class based on the interface, right? Also remember that I can compare the two. Does Antihero have malice? Yes. If I can test for that. If Antihero has malice, it comes true, right? And I can do the same thing for supervillain, right? Supervillain and antihero kind of have that relation, right? And the same thing goes with superhero. Superhero and antihero kind of have the same thing. They have karma to some degree, right? They feel bad, when they do bad things, right? And that's kind of the weird thing. When a supervillain does bad things, right? He's okay with it. He has no karma. He doesn't care. He wants to gain malice, right? A true supervillain. And a superhero, that's a different thing altogether. He does anything bad, he loses karma, right? And but what about this anti-hero? He kind of, if he does both, does he lose karma and gain malice? Kind of. That's what happens, right? He kind of feels bad in one way, but it feels good because he's doing what he has to do, right? So that's kind of a more complex, and that's why we love anti-heroes when we watch them on TV, right? They're not as vanilla, I would say, as watching a superhero. Superhero is only good. That's all he does all the time with all his limitations. We've seen that pattern many, many times. And now, of course, we've seen the anti-hero pattern as well, right? When we watch movies. But he's more interesting to look at because of the conflict that's inside of them from a story perspective, right? I digress. The idea here is that you're trying to take this concept, this abstract concept of anti-hero, and code it. And that's what this whole thing is about. So we modified our program because we're implementing the anti-hero class, right? That's what we did here in 0.6. Okay. And of course, I'm going to put this up on GitHub. So I'm going to go to Team Explorer. Team Explorer, I'm going to go to Changes. I'm going to say implemented anti-hero class in the driver class. All. I'm going to go to Home, and I'm going to go to Sync, and I'm going to go to Push. All right, cool. There we go. Right, so I pushed it. Let's take a look at what that GitHub repository looks like now. And I think I want you to understand this because, you know, some people said, well, Tom, I only have like 4 commits. Is that enough? I laugh at that. I really do. Because I want you to take a look at 10A and tell me how many commits we have, right? We have 7. Now, this is why do we only have 7, right? Now, this is 7 based on what we did with from 9 to 10, right? Last week, we made a bunch of commits on version 9, on our lesson 9. So if you were to take those to give you an idea of how many commits you need to do to a real project, right? A real project. So let's say 9B or 9A. We'll say we'll stick with the A's, okay? So 9A, we ended up with 20 commits, 9A, to build up to what we started with this week, right? Plus another 7, that's 27 commits we have altogether. 27 commits, or 26, let's say, roughly, okay? Because you lose a commit because they made another project, or 2 commits. So let's say 25 commits. 25 commits to get me to this point, right? So when I look at your code, when you hand it in for next week, Friday, when it's due, and if I see 4 commits, what does that mean to me? That means you just put it up on GitHub and see you later, Tom, right? That's not the solution. That's not the answer here, guys. I'm not showing you GitHub, and you're not going to satisfy me by putting up 4 commits or 3 commits or something like that. And I don't want to empty useless commits either, right? Because if I look at the commits, each one of them has something that we're doing, right? They tell a story about how you're implementing, how you're developing, right? Each one of these has a valid thing. I'm not going to make a commit that says A, B, or LKB. Some people just like do random stuff on their keyboard and just make a commit. Commit 1, commit 2, commit 3. That's also wrong. I don't want to see commit 1, 2, 3. It means nothing, right? Make your commits, have your commits to make a story, right, of your development. This is showing me how you've developed your code from day 1 until your current version, right? And that's what I'll be looking for. Okay, enough talk. Let's get to the little quiz we're going to have. I'm going to stop recording, right? And I'm going to activate the quiz. So I'm going to go to quizzes. That's where it is right now. And the quiz right now is inactive. I'm going to make it active. You have 50 minutes. You're going to have 2 attempts. I recommend you do both attempts, right? To do 2 in 15 minutes, right? That's what I want you to do. Here it is. And the password for this one, I'm going to tell you when I stop recording. All right, I'm going to stop recording now.